Record na tayo, guys. Okay. So, on this session, where we're going to discuss radiation. Ano? So, if you still remember last meeting, we tried to solve thermal conductivity problems. So, today we're going to look at radiation. Basically radiation heat transfer. I'm going to share the PowerPoint. Okay, so ito yung di-discuss natin today. Okay lang ba? Nakikita niyo na yung PowerPoint? Ano yung PowerPoint? Okay. Radiation heat transfer. Basically tatlo yung way para ma-transmit yung heat. So yung una nga yung conduction. Yung diniscuss natin last meeting. And then syempre merong convection, ano? Yung convection naman is halimbawa you have liquids and then mababa lamang yung heat, yung conduction ng ng gas at saka ng liquid, no? So most of the heat transferred from liquid and gases is through convection, ano? Pero meron pa rin kasing isa, ano? That's radiation. So ito yung halimbawa naka-black ka na t-shirt, mainit, ano? As compared halimbawa pag naka-white ka na t-shirt. 'Di ba? It's relatively mas presko pag naka-white ka na t-shirt, ano? So ito yung heat transfer na related, ano, dun sa color ng suot nyo. So this is radiation heat transfer. Okay, so basically yung marami rin ditong concepts, marami ring concepts. Tapos merong one or two problems tayo probably madi-discuss. One or two types of problem tayong madi-discuss. So of course, you're all familiar with this reflectivity, absorptivity at saka transmissivity, no? Gusto naman kayong mag Chem 130, Chem 32, analytical chemistry. So analytical chemistry, probably na-encounter niyo na yung absorptivity at saka transmissivity. Tama? So basically pag sinabing absorptivity, ito yung light or yung radiation na na-absorb ng material. Tapos yun namang transmissivity, ito yung amount ng light na natatransmit niya, no? Yung nakakalusot. Okay, yung reflectivity naman yung nare-reflect, of course. So, pag merong incident radiation or incident light, so itong tatlo na to, ito yung possible na mangyari doon sa incident light. It's either it is reflected, absorbed, or transmitted. Okay? So, ang reflectivity kasi R din siya, no? It's represented by rho. Ito yung reflectivity. Okay? Tapos yung absorptivity is alpha. Tapos transmissivity is tau, no? So tau. Tapos pag sinam niyo yung tatlo, uh, there's the sum is 1. Ano? Okay? So Yun lang naman yan. Ano? Pero pag reflection, yung reflection yun yung generally yung nagiging kulay ng ano no, nung object. Yun yung reflection. Yun yung bumabalik sa mata natin. Ano? So, halimbawa, yung leaves kulay green. So ibig sabihin, nire-reflect niya yung green na ano, na radiation na color, no? So, ang na-absorb niya yung halimbawa yung blue at saka yung red. Ganun. Tapos transmit since opaque naman yung leaves, probably zero yung transmission niya. Parang ganun yun. Ano? So it's either pag leaves ang pinag-uusapan, meron lang siyang reflection at saka absorbance. Parang ganun to. Okay, so gases and radiation. So pag monoatomic gases at saka diatomic gases, halimbawa helium, monoatomic gases yon. Tapos oxygen, diatomic gases yon. These are transparent, no? Transparent gases, transparent to radiation. Ibig sabihin, yung absorptivity nung mga gases na to ay zero. 'Di ba? Parang tinatawag nating colorless. So these gases are colorless. So yung light, as you will imagine, lampasan lang sa mga gases na to. As opposed to sa mga polyatomic gases like water, carbon dioxide, and ammonia. So nag-absorb to ng light. Ano? So say for example, ang carbon dioxide, di ba? Kaya nga nagkaka-global warming kasi nag-absorb siya ng light. Tapos pag ini-emit niya, iba na yung frequency, no? So kaya natatrap na siya dun sa atmosphere natin, no? Pero yung mga monoatomic gases, hindi yun nagko-cause ng ano, ng climate change, ano? Kasi hindi sila nag-absorb ng light. Unlike carbon dioxide. Ganyan lang naman yung example. Ano? So as you can see, more of ano, concepts din lang to. Ano? Mga basic din lang naman. Okay, pag black body. Pag black body, it's a physical ideal case. Ano? So pag black body, sinasabi natin na absorptivity is equals to 1. So absorb lang siya ng absorb. Ano? Pag merong tumama sa kanyang radiation, absorb lang siya ng absorb. So parang you can relate this, pero syempre it's not exactly. Halimbawa, you're wearing a black shirt, ano? 'Di ba mainit, no? Kasi yung black shirt, absorb lang siya ng ano, ng radiation. Tapos ang reflectivity niya zero, ang transmissivity niya ay zero. Pero syempre, hindi naman literal na pag black yung color ng object, ang absorptivity niya is equal to zero, no? So this is an ideal situation na pag black body, ang definition natin yan sa physics, ang absorptivity niya ay 1. Okay? So concepts lang naman to. Ano? Okay? So magsabi lang kayo pag may ano, pag may problema. It's first time kasi nating mag-zoom. Okay, then we have the emissive power. And emissive power is represented by W. No, itong W na to. Yung WB, this is the emissive power of a black body. Tapos emissivity. Yung emissivity is emissive power divided by the emissivity of a black body. So, expect na yung emissivity, ang range ng value nito is from 0 to 1. Okay? So, sabi dito sa statement, the surface of a perfect black body with an emissivity of 1, yun yung definition natin ng ano, another definition of black body, emits a thermal radiation of approximately 448 watts per square meter. Okay? At a room temperature of 298.15 Kelvin. Okay. So, imagine nyo, no? Relatively mataas yan, no? 448 watts per square meter at 25 degrees. This is at room temperature. So, ang tawag sa constant na yan ay sigma. Meron ba kayo sa physics? Na-encounter niyo na to sa physics, yung sigma? So, if you're using a... Kita niyo ba ako sa ano? Sa camera? Kita niyo yung calculator. Kita niyo yung calculator. So, if you're using a uh, if you're using a class width calculator, you can retrieve the value of sigma, no? So sa class width, most of you naka-class width na, ito na lang kasi nabibili ng madami sa market. You can access this constant by pressing shift. You have your calculator with you. So try to press shift. On nyo muna, press shift, tapos constant, and then nando siya sa physicochemical, number 4, no? So number 4, okay? Tapos number 9, yung sigma. Okay? And then press equal. So this is approximately, yung sigma natin is approximately 5.67 times 10 to the minus 8. Nakikita nyo sa calculator? Yung 5.67 times 10 to the minus 8. No? So in order to get that 448, ang unit kasi nito is watts per meter squared, no, per square meter per Kelvin to the fourth. Okay? So para makuha niyo yung 448, i-multiply niyo siya ng 298.15 raised to the fourth power. So i-multiply niyo to ng times 298.15 raised to the fourth power. So yun, nakuha niyo yung 448. Yun yung ini-emit na thermal radiation ng perfectly black body, ng perfect black body, ano? So actually medyo mataas yan, ano? Makikita niyo mamaya sa problem. Medyo abstract din tong radiation na to eh. Pero basta ang mahalaga lang naman dito, medyo nasusolve lang natin yung mga classic sample problem and then you're good to go. Pero marami kasing concepts. Maraming concepts dito sa radiation. So kamukha din sa viscosity, marami ring concepts that you really need to be familiar kasi lumalabas din talaga sa board exam. Okay, so just try to ask questions. Probably you can use your mic kung gusto niyo magtanong. Medyo hindi ko ma-access sa ngayon yung chat. Okay, so do you have any question regarding this 448 watts? So sigma lang yan times 298.15 to the fourth, no? W is emissive power, WB is emissive power of a black body, and then yung ratio ng W sa WB, we call that emissivity. Yun lang naman yun, ano? These are the emissivity values of different material. So as you can see, it ranges from 0.02 for metals to 0.95 for papers, no? Sa paints, yan, mataas din yung sa paints, ano? So you can paint something probably with a black paint and then yung kanya magiging black body siya. Parang ganun. Parang ganun yung sinasabi nitong PowerPoint na to. Ano? Itong slide na to. Okay? And then this is the most important equation, no? Sa radiation. This is the Stefan-Boltzmann law. So sabi ng Stefan-Boltzmann law, the emissivity of a black body, so the emissive power of a black body is equals to sigma, okay, times T to the fourth. Yung sigma, ito yung constant sa calculator natin, ano? So this is known as the Stefan-Boltzmann constant, yung sigma na yun, ano? T is in absolute temperature. So ito yung na-retrieve natin sa calculator kanina, yung 5.67 0373 times 10 to the minus 8. So ang unit nun ay watts per meter squared per K to the fourth. Kung gusto niyo naman ng English, wala to sa calculator, you need to memorize this. 0.1713 times 10 to the minus 8 BTU per foot squared per hour per Rankine to the fourth. So ito ay minememorize to pag English yung problem. Ha? Kaya buksan nyo na lang yung in-upload ko naman tong PowerPoint. Pero memorize nyo rin. Ito nasa calculator lang to. Okay, so gagamitin natin yan mamaya sa problem natin. Ano? Itong Stefan-Boltzmann law. Usually ganito yung lumalabas sa board exam na problem sa radiation. And of course, the concepts. And then itong Wien's law. So ang Wien's law, basically sinasabi ng Wien's law yung lambda max, do you still remember lambda max sa analytical? Yung lambda max, ito yung wavelength of maximum absorbance. Ano? Yung wavelength of maximum absorbance is inversely proportional sa absolute temperature. Okay? Yun lang naman yun. So, pag mas mataas ang temperature, mas mababa yung kanyang lambda max. Okay? So, yung C, yung constant is 2,890. Pag yung temperature ay Kelvin, this is, your lambda max is in micrometer. And then 5,220 is in Rankine. So, yun. Ganun pa rin. Lambda max is in micrometer. Question? Open your mic and ask your question. Ano kayo nahiya? So, lambda max is the wavelength of maximum emission. Ano? So, parang ganyan yan. Ano? So, pag, tingnan nyo, pag mataas yung temperature, 2,000 degrees Fahrenheit, yung lambda max niya mas mababa. It's approximately 2 micrometer. No? So, pag halimbawa, 1,500 degrees Fahrenheit, so yung lambda max niya, nasa 2 point something. No? So, pag bumababa yung temperature, tumataas yung lambda max niya. So, pag 1,000, andito na siya sa 4. Okay? Inversely proportional. So, buksan nyo lang to kung tinatamad kayo mag-memorize. And then, these are the constants C, 2,890. Ano? Yan. So, let's try to solve this Wien's law example. Is to estimate the lambda max of an object according to Wien's law at 298.15. So, basically, i-divide nyo lang yung 2,890 ng 298.15. So, ang lambda max ng at 298.15 is, ano nakukuha niya? I'm getting 9.69 micrometer. So, diba, lambda max is equal to 2,890. This is a constant C divided by 298.15. So, lambda max is approximately equal to 9.69 micrometer. Do you have any question regarding Wien's law? So usually naman, so far, ang nakita lang namin sa board exam nito, concept, no? So parang tinatanong lang niya kung ano yung law sa radiation na that tells that the lambda max or the wavelength of maximum emission is inversely proportional to temperature. Okay? Questions? Okay. Kanina meron tayong black body. Ngayon naman, let's define a gray body. Ang gray body naman, the absorptivity is constant for all wavelengths. No? So, gray. Kasi di ba pag gray, pag tatandaan nyo pa sa arts natin ng elementary, pag pinaghalo-halo nyo lahat yung kulay, ang kalalabasan ay kulay gray. No? So, pag yung absorptivity niya, constant for all wavelengths, we call that a gray body. So kahit saan mo pa i-measure yung, kahit ano pang wavelength mo i-measure yung absorptivity, pare-parehas lang yung absorptivity niya. Kahit ano pang color, ang tawag dun ay gray body. No? So when the absorptivity is constant for all wavelength, we call that a gray body. No? Concepts din lang. Tandaan nyo lang. Kanina black body. Pag black body naman, yung kanyang absorbance ay 1, no? So lahat na-absorb niya. Walang lumalabas, Kaya mainit pag nakasuot ka ng black. Yun yung tinatandaan namin, di ba? Absorptivity is equals to 1. Ito naman, gray body naman, lahat ng wavelength, kahit anong wavelength, no? Equal lang yung absorbance niya, absorptivity niya. Pag sinabi namang opaque solid, ito naman yung hindi transparent. So, sa opaque solid naman, transmissivity is equals to 0. Okay? So, ano lang naman, di ba? Parang common sense naman. So, opaque, so hindi siya transparent, so transmissivity is equals to 0. Marami na importante dito, ano. So expect this in the, ano ha, expect this concepts in your prelims. And then the Kirchhoff's law. So ito rin, concepts din lamang to. Ang sinasabi lang ng Kirchhoff's law, yung, remember this W is emissive power, ano, W is emissive power. Tapos yung alpha, alpha naman is absorptivity. Okay? Remember, yung alpha is absorptivity. Absorptivity. Meron pa ditong P, absorptivity. Check na lang may spelling. Pero tama naman siguro. So, alpha is absorptivity. Parang, di ba, tatlo yan, no? Transmissivity, absorptivity, at saka yung reflectivity. So, yung alpha dito. Sinasabi lang ng Kirchhoff's law, the ratio of emissive power and absorptivity is constant. Okay? Yun lang yun. Ano? Tatandaan nyo lamang yan. Ano? Of a particular body. No? So, halimbawa, pag black body, yung emissive power niya divided by its absorptivity, palaging WB. No? WB. WB, WB. Kasi absorptivity ng black body 1. Ano? Okay? So, anyway, basta ano nyo lang yun. Just try to remember that. Kirchhoff's law. Marami kasi tayong law dito, di ba? The Wien's law, the Kirchhoff's law, then the Stefan-Boltzmann law. So, puro concepts, no? Okay. Napunta na tayo sa problem. So sa problem, ang bago dito is yung pagka-calculate ng heat of radiation. So in order to calculate the heat of radiation, we're going to use this equation. Ano? So if you will notice, itong sigma times T to the fourth, yan yung Stefan-Boltzmann law. Kaya lang hindi naman kasi palaging 100% yung ating emissivity. No? Yung emissive power, hindi naman palaging 100%. So kaya minumultiply natin siya ng emissivity. No? So dito pumapasok yung kanina. I-extend naman yung zoom. Yung iba. Nakita nyo rin ba yan? Kunwari 40 minutes pero yun, as you can see, extended naman siya. we can extend it. So until ata may pandemic, ganoon pa rin sila. No? So pag nawala na, yun na lang nila. Okay. So basically itong emissivity na to is less than 1. So i-multiply nyo lang dun sa constant galing sa calculator. Remember, this is your sigma, no? Ito yung Stefan-Boltzmann constant, tapos yung temperature, absolute temperature to the fourth. Tapos ito yung heat flux, Q over A, you know? Ito generally ito yung formula natin ng heat of radiation. Okay. So pag kinumbine natin siya, usually ang problem kasi pinagko-combine yung tatlo, conduction, convection, and radiation. So yung Q total divided by area is generally equal dun sa Q convection. Usually pag gases kasi, saka pag merong involved na radiation, minimal lang yung conduction. No? So generally this is convection. Yung C dito, conduction, convection na rin yun. No? So itong QC over A, ito yung formula niya. HC, ito isang variable lang to, isang constant lang tong HC. This is the heat transfer coefficient. Ano? So basta constant lang to, ano? Then i-multiply nyo sa difference in temperature. Usually, TW is the temperature of the environment. Ano? Ito naman yung temperature. Yung T dito, this is usually the temperature of your tube. Usually kasi tubo yan, tapos yung kabilang temperature, yung temperature ng air. No, usually ganun yung mga problem. So that's why this is TW. Basta ito yung environmental temperature. Ito yung temperature ng tubo. No? Usually ito yung, generally ito yung mataas. Kung ano yung mataas, ano? Ito yung isang temperature. So, this is heat transfer coefficient. HC, ano? Sa ano to, generally sa convection to. Hindi pa naman natin na-discuss yung convection. Pero basically, ganyan lang naman kasimple. I-multiply mo lang yung heat transfer coefficient dun sa delta T. No? Tapos actually, ito yung pinag-aaralan natin. Ano? Ito yung heat of radiation. So, sigma times emissivity times the port of TW minus T to the port. Okay? So, let's try to answer this classic problem. Ano? You have a 5 centimeter outside diameter steam pipe. Okay? So it's a pipe, ano? Tapos ang kanyang outside diameter is 5 centimeter. This is 10 meter long. Tapos this is insulated with 1 centimeter. Merong hindi niyo nakikita, no? Sorry, hindi ko na You can change this, ano? You can change this camera, ano? Pwede niyo i-reduce siya na gano'n, no? Pwede niyo yung nakita niyo yung control ng camera para mabasa niyo to, ano? So yun. So this is insulated with 1 centimeter of magnesia. Babasa niyo na ng buo yung problem. Insulation whose surface temperature is 60 degrees Celsius. And surface emissivity is 0.85. Ito na yung E, no? Ito yung TW natin, 60 degrees Celsius. Okay, if the insulated pipe is exposed to air and surroundings at 30 degrees Celsius, calculate the heat loss in watts from the pipe to the surrounding. The convective heat transfer coefficient of air is 8.5 watts per meter squared per Kelvin. Okay na? Do you have any question regarding the problem? So yun yung sagot, ano, 970 watts. So, basically, yung formula lang natin is Q, ito na yung Q total, ano, over A is equals dun sa HC, no? Times yung TW minus T, okay? Plus, yung sigma, yung sa calculator natin, times emissivity, times TW to the port, minus T to the port. So, substitute na lang dito. Ano? Substitute na lang dito. So, yung HC muna natin. Ano? So, 8.5 times watt. Watt meter squared per Kelvin. Tapos yung mga temperature natin. Di ba? 60 at saka 30. So, 60 minus 30 lang yan. This is in degrees Celsius minus 30 degrees Celsius. Alam niyo naman, di ba? You can cancel out Kelvin and degrees Celsius pag range. No, magka-cancel out lang yung conversion. Okay. So let's continue to the radiation part of the equation. So plus, yung sigma natin yung nasa calculator, ano? So just retrieve sigma sa calculator and then emissivity is 0.85 or this one, 0.85. Tapos, convert yung temperature sa Kelvin, yung 60 degrees Celsius. So, try sa calculator nyo, that's 333.15. Just raised to the port, this is in Kelvin, ano? Minus ito, that would be 303.15 raised to the port. No? So just use your calculator. Kuha ng calculator para hindi mainip. So, pasok nyo yan. So 8.5, okay, times 30, 60 minus 30 plus 6, no, that's not 6, that's shift constant for 9, that's sigma, ano, times 0.85 times 333.15 raised to the port minus 303.15 raised to the port. Ay, sorry. Makit siya dun sa minus 4. So, space nyo muna, ano, or forward nyo muna bago kayo mag-minus. Yung 303.15. Tapos raised to the 4. Space ulit bago maglagay ng ano, bracket. Or, you call that, parentheses, ano? Tapos equal. So, from this, I'm getting, ano, 441.67. Mga ganun, ano? So, this is equal to approximately 441.67 0.67. Pero syempre, ano pa lang to, ano, watt per meter squared. So, ang tinatanong kasi is the wattage, ano? So, we need to calculate the area. Yung area ng pipe. Ano ba yung area ng pipe? Yung sangkot sa heat transfer. So, yung area ng pipe na sangkot sa heat transfer is ito, ano? So, ang kanyang length ay 10 meter. Imagine niyo pag parang binukan niyo yung pipe, anong i-multiply niyo sa 10 meter? Anong formula ng area ng cylinder? Anong formula ng area ng cylinder? Di ba ano yan? Ito, di ba? Circumference times the length. Okay? Anong formula ng circumference? 2 pi r o kaya pi d, no? So ang formula ng area ng cylinder natin ay pi d L. So yan lang yan, ano? So we need to determine the diameter. Ang length natin 10 meter. Yung outside diameter ng pipe 5 cm. Ito, 5 cm yan. Tapos naglagay kayo ng magnesia na insulation na 1 cm. So ilan na yung total diameter ng pipe? 1 dun sa taas, 1 dito sa baba. So ang D natin ay 7 cm. Diba? Okay, so now let's calculate the area of the cylinder. So that would be pi, tapos times 7. Centimeter yan times 10 to the minus 2. Okay? Tapos yung length ay 10 meters. Okay. So itong area na to, i-multiply nyo dito para makuha nyo yung 970. Okay? So let's do that. We're going to multiply this and then tingnan nyo kung ano magiging sagot. Masyado palang masakit sa mata yung red. Sorry. Next time, I'm going to use probably white. Pasensya na ha. Ngayon ko lang na-realize ang sakit pala sa mata ng pula. Okay, so get your calculator. Multiply nyo yung 441.67 times shift pi times 7 exponent minus 2 times 10. What do you got? You got the 970 watts. Ano? You got this one from your calculator? Get this one? Kasi meters per to, ano? So multiply nyo lang itong area. So ang area ng heat transfer, ano ma-imagine nyo, ay yung perpendicular dun sa direction ng heat. Ha? Okay lang? Hindi yung cross-section. Yung mismong metal ng pipe, dun nagkakaroon ng heat transfer. Hindi siya dun sa butas ng pipe. Nagkakaroon ng heat transfer dun sa metal. Ng radiation heat transfer dun sa metal. Actually, kahit naman yung isa convection, ano? Kahit naman dun sa convection, dun pa rin sa ano, yung paring metal ng pipe. So, yun yung kinakalculate nating area. You need to realize that. You really need to realize that. Unless, kasi pag hindi nyo na-realize yun, hindi magiging stock knowledge. Hindi nyo magiging stock knowledge yan. Kailangan nyo talagang maintindihan bago nyo maging stock knowledge. Kasi pag mechanical lang yung dating, ginagamit nyo lang yung formula, madali nyo rin makalimutan yan. Tsaka hirap na hirap talaga kayo. You really need to understand. No? You need to understand the phenomena. So for you to remember and understand the problem. Actually, pwede nyo gawin yun. Kaya lang mechanical. Questions? You can ask questions. Diyan pa ba kayo? Ilan na ba tayo? Oh, we're 29. Dami na pala natin. Ano? We're 29. Very good. Okay, do you have any questions? So let's proceed. Hoping that we can still solve some more problem. Ano? Sabi ko naman sa inyo, dalawang klase lang naman. Ano? So ito naman yung merong view factor F or angle factor F. No? So we're going to consider two cases. No? yung pinaka-practical cases lang. So pag tiningnan niyo yung equation, this equation na gumagamit ng view factor, basically ang nangyari lang naman dito, yung emissivity, napalitan lamang ng view factor F o kaya ng angle factor. Ano? Napalitan lang yung E ng F. So merong lang mga equation for F. So may memorize nyo lang yun o kaya silipin nyo lang dito sa PowerPoint pag nag-exam tayo. And then, basically, yun lang yung gagamitin nyo together with the Stefan-Boltzmann equation to solve the problem. No? So, ang concept lang kasi nito, pag view factor yung kino-consider, hindi kasi kuminsan kasi hindi, yung radiation, dependent siya sa angle. No? Yung emissivity dependent sa angle o kung paano tumatama yung light. No? Halimbawa, di ba, meron kayong solar panel. So alam niyo naman yung solar panel, tayo nasa equator tayo, no? Mas malaki, mas madami siyang na-absorb pag yung light rays directly perpendicular dun sa solar panel, no? Yun yung pinakamataas yung efficiency. So pag medyo hindi na siya perpendicular dun sa light rays, bumababa na yung efficiency. Kaya meron tinatawag na view factor or angle factor, F. No? Ganun lang naman yung explanation niya. So, ang i-consider lang natin, yung dalawang spatial case. Yung parallel, no? Yung parallel plates, at saka yung concentric circles. Yun lang naman yung lumalabas sa board exam natin. Marami pa kasing ibang case. Pero yung makay-makay lang na cases, yung i-consider natin. Parallel plates at saka yung concentric circles. So may formula lang naman ng F yun. As you can see right here, meron pang iba-ibang kinonsider si Mackay, pero hindi naman niya minigay yung mga equation dyan. Parang illustration niya lang to. So let's take a look at the equation for view factor. Okay. So ito yung formula ng F if you have two large parallel planes, no? So ginagamit kasi ito sa manufacturing. Halimbawa, nag-heat treat kayo ng yung mga yero, no? Yung mga stainless steel na sheets, no? So ito yung usually kasi meron dalawang plates na mainit tapos yung hini-heat treat niyo na yero nasa gitna, dumadaan sa gitna. Ganun yung setup sa industry. So that's why important itong itong angle factor equation na to. So basically pag two large parallel planes, no? Ang equation is 1 all over 1 plus E1. Ito yung emissivity nung plate sa taas plus 1 over E2. Ito yung emissivity nung plate sa baba, no? Minus 1. Kasi dalawang parallel planes, So, this is the formula for two large parallel planes. Tapos, this is for concentric sphere. Na-imagine nyo, you have two spheres bilog, tapos yung isa maliit, nasa loob ng isa. So, yung isa nag-i-emit ng radiation, yung isa nagre-receive. Okay, so ito yung equation ng angle factor, So 1 all over 1 plus emissivity 1 plus emissivity parenthesis emissivity 2 minus 1 times A1 over A2. Yung A1, this is the area of the smaller sphere. Tapos syempre yung E1, this is the emissivity of the smaller sphere. Okay? So let's try to solve some radiation problem na gumagamit ng angle factor. So para makita nyo, i-minimize lamang yung camera. Hindi ko na-adjust Pasensya na kayo. Marunong na kayo mag-adjust ng camera dito? Ito, nakikita nyo lang yung mga option dito. Nakikita nyo ba? Click-click nyo lang ito, ha? So, this is from McCabe, Example 14.1. I think this is from the 7th edition or the 6th edition. Hindi ko lang alam kung meron sa 5th edition. Pero if I remember right, I get it from the 7th edition. May solutions manual naman to. Pero ito, this is an example. So, nandun talaga yung solution sa libro. A chamber for heat curing large aluminum sheets, painted black on both sides, okay, operates by passing the sheets vertically between two steel plates 150 millimeter apart. Na imagine nyo? So, heat curing. Why do we heat cure metals? Pag nag-material science kayo, mapag-aaralan nyo doon, pag ininit nyo yung metal, nagkakaroon siya ng imperfection. Tapos yung imperfection na yun, medyo counter-intuitive, lalo siyang nag-i-increase yung strength, no? Pag may imperfection. So ganun yung nangyayari. That's why we heat cure, no, metals. Parang nagsasala-salabat yung mga molecules niya. Tapos lalo siyang tumitibay. Ano, parang ganun yung nangyayari. So these are painted black on both sides. And then, ang mahalaga dito yung temperature. Ano? One of the plate is 300 degrees Celsius and the other is 25 degrees Celsius. Tapos, yung aluminum nyo nasa gitna. Ano? Imagine nyo? Basically, parang tatlong parallel sheets. Yung aluminum nyo nasa gitna, yung tinitreat nyo. What is the temperature of the aluminum sheet? So, yun yung tanong. So, syempre, ang assumption nyo dito, walang heat losses, walang radiation heat losses. So, kung ano yung radiation between the first and the second is the same as the radiation heat between the second and the third. So, equate nyo lamang yung dalawang radiation equation. Okay? So, basically, magka-cancel out yung F at saka yung sigma. No? Magka-cancel out yun. Tapos, solve nyo lamang yung temperature ng aluminum sheet. Imagine nyo ba? Imagine nyo. Halimbawa, ito yung ano no, yung heating element sa taas. Tapos so let's call this the heating element. Hindi pa naman 11:30 ano. Tapos ito yung aluminum, yung aluminum. Yan ano. Tapos you have another element here, ano? Metal element. Metal element. Parang kumbaga parang itong huli, ito yung pansangga nung heat ano para mas efficient siya, para walang losses. Ano? Okay? So ito, ang temperature nito 300. Ito ang temperature nito 25. Okay. So kamukha nung ginawa niyo na ba yung exercise nyo? So kamukha nung sa exercise nyo, kung ano yung QR dito, radiation, yung QR2 dito, radiation 2, equal lamang itong dalawa nito. No? Yun yung ganun lang yung assumption natin. Okay? Okay, so let's try to solve this. Ano? Probably, para hindi masyadong magulo, I'm going to share a whiteboard. So kamukha nung drawing ko kanina, ano, tatlong plates. Ito yung aluminum. This is 300 degrees Celsius. Kulay black, di ba? It's painted. Tapos this is 25 degrees Celsius. So sabi ko nga sa inyo, yung equation natin dito, yung radiation 1 is equal din sa radiation 2. So yun, okay. Ano bang formula nitong radiation 1? Ang formula ng radiation 1, kasi nga angle factor na tayo, is F times sigma times yung 300 degrees Celsius. Okay? Gawin ko ng 300, ano, 300 plus 273. That would be 573.15 to the fourth minus yung temperature ng aluminum to the fourth. Okay? Tapos this is equal dun sa F times yung factor, yung whatever, Stefan-Boltzmann constant. Okay? Tapos times yung, siyempre aluminum yung mas mataas to the fourth, minus yung, this one, 25 plus 273, this is 298. Tapos, solve nyo lamang yung ano, yung temperature ng aluminum. Just use your calculator. Ang mangyayari dito, ito magka-cancel out. Now, Madadali lang naman actually itong mga to. Kailangan lang talaga alam nyo. Kasi kung hindi nyo na-encounter, paano nyo sasagutan yan? Eh, to the fourth yan. Hindi nyo makakapayan, di ba? Familiarization lang yun. Okay. Try to use your calculator. Get your calculator. Get your calculator. Um, alpha x. Okay. Tapos ship solve. Medyo matagal nga lang yun. Ano? Okay. Anong lumabas sa inyo? Hmm? Siya. Yun, tama. 490.55. Very good. That's correct. 490.55. Ano? So, ganun lang yan. Ano, pag parallel sheet. Tapos tinatanong yung temperature ng nasa gitna. Ganyan lamang yung solution. Okay? Ay, i-share ko ulit yung. Ito yun. Ano? Ito yung 490.4 na yun. Pwede siguro hindi siya gumamit ng 0.15. Ano kaya 490.4? Pakicheck na lang kay ano, kay McCabe. May ebook kayo ng McCabe. Hanapin niyo rin yun. Kasi gagamitin din natin yung McCabe later. Pag nag-ano na tayo, fluid mechanics. Maganda kung meron na kayo mahanap na ebook ng 7th edition. Ako dati wala akong mahanap kaya bumili ako ng 7th ed. Ang laking ganda na ng 7th ed sa ano. Usually 5th ed yung nakikita eh. Luma na yung 5th ed, 90s pa. Alam mo pala, laki ng improvement ng 7th ed. No, nawala na yung mga mali-maling sagot. Tapos may solutions manual na rin yung 7th ed. Okay? So let's try to solve letter B. Letter B, what is the heat transfer between the walls? No? Between the walls when equilibrium has been reached. Emissivity of steel is 0.56 and emissivity of aluminum sheet is 1. So ito yung E1, ito yung E2. Tapos gagamitin natin yung emissivity equation for parallel plates. Ito gagamitin natin itong formula na. No? Okay? Tapos syempre, pag na-calculate na natin yan, gamitin natin to to calculate UR. UR over A. Imagine na? So you need to memorize this. You need to memorize this. Pag magbo-boards na kayo, ang ina-advise namin, sulat na sa sa yellow paper or sa piece of paper lahat ng mga equations. Tapos memorize na talaga, no? Tapos meron pa kami tinuturong technique na download. Pinapasulat na namin in advance sa piece of paper yung mga formula before mag-solve, before mag-solve. Hindi lang naman yun. Anyway, it really depends on you. Kung tiwala naman kayo sa memory nyo, okay lang kahit hindi nyo naisulat pag nag-e-exam. Okay? Kita nyo naman yung magiging sagot natin, watt per meter squared. Wala naman kasing given na area. So, per meter squared lang yung sagot. Let me share a whiteboard. Kita nyo, ang bilis dito mag-share ng hindi na siya naglo-load. Hindi katulad sa collab. Pero magkukulab pa rin tayo sa Thursday na tayo. Thursday ulit tayo. Thursday collab tayo. Ito i-upload ko itong video na ito. I-upload ko sa YouTube tapos upload ko rin sa Mas gusto ko pati yung ano nito, hindi lang kasi kayo nagbubukas ng camera nyo eh. Isipin nyo, pag nakabukas camera nyo, lalabas kayo. Hindi ba masaya? Tapos alam nyo naman gamitin, di ba? Pindutin nyo lamang yung down arrow dito sa baba. Yun. Makikita nyo yung mga nakabukas ng camera. Saka yung mga picture. Yung mga picture sa Google, sa Gmail. Ayun. Mas maganda yung interface nito. Okay. So, solve muna natin yung F. Pag parallel plates, ang formula ng F ay 1 over 1 over E1 plus 1 over E2 minus 1. Okay? So, kalimutan ko na ang E1. Ano, pwede ko naman ito dito. Ayan, dito pa. Hila. Ito. So, ang E1 ko ay 0.56. Ano? 0.56 ang E1. So, 1 over 0.56. Tapos, ang E2 ko ay 1. Diba? 1.0 tapos minus 1. So, actually, mangyayari dito, this is plus 1. Ang mangyayari dito, magka-cancel out lang yun. So, ang F nyo ay 0.56. Tapos, ang QR over A, ang formula natin ay F times yung Stefan-Boltzmann constants, tapos TW to the fourth minus T to the fourth. Ito yung T to the fourth yung na-calculate natin kanina, yung 490.4 Kelvin. Ano? So, substitute lang natin 0.56. Ito, i-retrieve nyo lang naman ito sa calculator nyo, yung Stefan-Boltzmann constant. Tapos yung TW natin to the fourth ay 573.15. 300 ano? 300. 573.15. To the fourth minus T to the fourth. Palagi ako naglalagay ng 0.15 na. So sa exercises nyo, maglagay din kayo ng 0.15. Parang i-add nyo sa degree Celsius 273.15. So pag hindi kayo naglagay, probably baka malian kayo. Kaya nga tatlo yung attempts. So baguhin nyo na lang ha. Lalagay kayo ng 0.15. Tapos ito ay 490.55 yung ginamit. Yung na-calculate nyo kanina, ano? To the fourth. So, just use your calculator to calculate QR over A. 0.56 times, retrieve yung constant, number 4, tapos number 9, tapos parentheses, 573.15 to the fourth, minus 490.55 to the fourth. So, it's approximately 1,588. No? Lapit naman dun sa sagot ni this is watt per meter squared. No? Malapit naman dun sa sagot ni McCabe. Okay? Balikan natin yung problem ni McCabe. Yan. So, ano? 1588. Si McCabe 1587. Hindi siya gumagamit kasi ng 0.15. Kaya ito lang yung temperature niya. Malapit naman yun. Questions? Do you have any question? You can ask questions. Okay. So, one last problem. Ito naman syempre, yung spherical, dalawang spherical na concentric. Okay, so determine the heat transfer. This is McCabe problem 14.1. So you can find these materials from chapter 14 of McCabe, and also you can find materials in radiation in chapter 14 of BSL. So under heat transfer pa rin to, ano? So determine the net heat transfer by radiation between two surfaces A and B expressed as watts per square meter of area B if the temperature of A and B are 500 and 200 degrees Celsius. And the emissivity of A and B are 0.90 and 0.25 respectively. Both surfaces are gray. Surface air is a spherical shell, 3 meter in 3 meter in diameter. And surface B is a similar shell concentric with A and has a 0.3 meter diameter. So pinapahanap dito yung QR over A. So bago nyo mahanap yon, kailangan nyo munang i-determine yung F. Tapos ano to, second case, ano? Concentric circle. So kailangan memorize nyo yung ating F equation for concentric circle. So, ito yun, ano? Ito. 1 over E1 plus time 1 over E2 minus, okay, 1 over E2 minus 1 times A1 over A2. Yung A1 is the area of the smaller sphere. Okay? Tapos ang ginagawa ko dito, yung A1 over A2, di ba pareho namang sphere yan? So this is, ang area ng sphere ay 4/3, di ba? 4/3 pi r cubed. Okay? Di ba? 4/3, this is R1, 4/3 pi r, 4/3 r squared. Ano 4/3 r squared? Area pala, sorry. R2 squared. Tama? Do you agree? 4/3 pi r squared. Tama na? Tama na? Anyway, basta ang mangyayari lang naman dyan, magka-cancel lang naman to. Whether it's quartered or not quartered. So, yung constant magka-cancel din lamang. So, you can use diameter. Ano? Area 1 over area 2 is just D1. This is also equal to D1 squared divided by D2 squared. Do you agree? Parehas lang naman yun. Tama? Kalimutan ko ng area. Tama naman ang area ng sphere ay 4/3 pi r squared. O mali. Google ko. Anyway, so let's try to solve this problem. Ito ulit ano? Ito naman. So 3 meters tapos 0.3 yung isa diameter ano? Tapos 0.9, 0.25. 500 and can you follow? 200. So let's try. I'm going to share a whiteboard. I'm going to clear this up. So yun muna ganun din, yun muna ng F. So ang F pag sphere cases ay 1 over E1 plus and then 1 over E2 minus 1. Tapos meron tayo ditong A1 over E2. Area to ng sphere. Okay. So, let's substitute the values. Yung 1, yun yung sa smaller, sa smaller sphere. So, 1.25 yung E1 natin, Kasi yung B yung yung B yung 0.3. So 1 is yung smaller. So ito yung 0.25. Yung ito natin yung 0.9 minus 1. Tapos yung A1 over A2, ano lang yan? Diameter squared. So A1 is 0.3 squared, tapos A2 is 3 squared. So ang F lumalabas ay, is your calculator to calculate F? Always have your calculator with you when we are doing Zoom, either Zoom or Collab, Para hindi kayo mainit. Yun din kasi yung isang problema sa sa online. Pero baka naman malapit na tayong bumalik sa classroom. Ano, ang dami na nagtatrial ng ano, ng vaccine, di ba? So, sana after midterm natin, after September may vaccine na. October. Ano yung October meron? Doon na tayo magpa-finals. MCL na. Meron na nagtatrial sa Cavite, di ba? AstraZeneca ba yun? O Moderna. Tapos meron sa PGH na Sinovac yung sa China. That's the sure. What do you got? 0.24? You got the 0.2499? 0.2499. You got this one? Tapos, yun na rin lang naman. QR over A is F, tapos sigma, tapos TW to the fourth minus T to the fourth. So, F is 0.25, that's 0.2499. Tapos yung sigma galing sa calculator. Ang temperature natin is 773 because that's 500, di ba? 500 and 200. So 773.15 to the fourth minus 200 is 473.15. Ilan ang ano? Ilan ang QR over A natin? Radiation, heat, flux. Shift, constant, 4, 9. Pag may bagong calculator, ano, pag bawal pa rin, pag hindi na naman siguro naman, pwede na to sa inyo. Anyway, basta may bago kayong calculator, alamin nyo kung paano nire-retrieve yung mga constant. Gano'n lang naman yun. Tinuturo naman yung sarili ko. Kaya ako na lang talagang gumamit ng mga calculator. Okay? You got, what you got? What answer do you got? Anyone? Dito pa ba kayo? Hindi pa naman time, di ba? Hindi pa naman 11:30. 11:11 pa lang. 11:11. Tama lang. Tapos na naman tayo. And then, I'm just going to leave you with an exercise. Tapos I'm going to post this para for those of you na ano. Kuha nyo? Sure answer. Tama. It's 4353. Ano? The correct answer. Madali lang ano? Madali lang talaga siya. Kailangan lang talaga na introduce, na ituro. No? Sandali-dali lang. So, let's go to the black whiteboard to the sinolve natin. Ano? Tapos, ito yung solution sa solutions manual. So, F muna, yung angle factor 0.25. So, tama ano? Ito yung angle factor natin. Ay, ang ginawa. Ito itong letter B. Letter B yun. Ito yun. Ito yung angle factor 0.25. Tapos, nasan yung final answer niyo? Dali lang ha. Ito pala. 0.25. Tapos ito yun. 4353. Kita nyo? Final answer? Ito wala yung pen. Anyway. Ito ha. Ito yung ano. Kita nyo naman yung pointer, di ba? Ito yung final answer. So do you have any question regarding these two problems? These two general problems? Yun lang naman, Stefan Boltzmann lang naman yung malaga dito, yung T to the fourth times your Stefan Boltzmann constant. Times your either your emissivity or the angle factor. So, okay, so, hanggang dito na lang muna, no? I'm going to upload this video sa YouTube. Tapos, magko-collab tayo sa Thursday. You know? Bukas, gusto niyo ulit mag-Zoom? Anong oras klase natin bukas? 8:30? Pwede ulit tayo mag-Zoom bukas. Ano? Titingnan ko na lang. Announce ko na lang, ha? So, for now, babay na muna. Attend kayo kung may collab kayo sa Zoom. Bye-bye. Sagutin niyo yung exercise. May pupusa kong exercise.